Okay. Hello again. 1 second, I might have a little echo because I need to be able to hear that the audio's going.
Hello again.
Okay, we're good. Good to see you guys for part 2. I was thinking actually that I want to start with a prayer today because of all the people out without electricity. So, Heavenly Father, we thank you for giving us the opportunity to come together and design a computer case. And thank you for all the warmth that you have given us. And we pray for all the people that are without power, that are freezing cold. We pray for the homeless people. And we pray for all the linemen and women who are working to restore power across the country. In Jesus' holy name we pray. Amen. My grandfather was a lineman, and when the big power outages would happen upstate New York, I mean, he'd be gone for quite a ways, and I kind of learned to respect that through my father. Just how hard they have to work and in the conditions they have to work. I also want to remind people today, too, that if you have an opportunity, you might want to call your local homeless shelter or food banks because they're going to be slammed after this week for sure. So see if you can either volunteer at the end of the week maybe or drop by some food or some money. But I just want to bring that up because, yeah, they're going to be slammed. Okay, anyway, let's get going. I actually don't know what I'm going to do exactly today because we have the case and I kind of showed y'all how I go about the process of making it, and we have a basic box right now. It's really boring, so I'm going to do the stuff that I know that I want to do with it, and I might doodle with it and experiment as well. I don't want to waste people's time though, so I might save that for like a part 3 or something. But what I do want to do is I want to add some features I know I want, and then I'm going to show you how I take this box and make it into something that you can actually submit to go get made. I want to show you that process because that's really important too, because once you have a 3D model, well, okay, now what do you do with it? So I'll definitely cover that. All right, so the first thing that I know that I want to do is I want to add some of my sky slots. So we're going to cover probably using a tool as a die, and we're going to cover patterns, which is important. I'm going to Alt-Tab here, and I'm putting this in the description. I've already updated the old description, but this is the ATX specification standards. If you're trying to wonder how you position parts or make a particular part, there could be a standard for it, so just do a quick Google. Just did a quick Google for this one. I knew it existed before, but there's lots of different standards. Intel, for example, has tons and tons and tons of standards. They have the ThinMini ITX standard, and so they'll have great documentation on how you're supposed to design parts and components and cases for their ThinMini ITX. Same for their NUC. They have tons of great documentation and drawings. They even have 3D models of the NUC boards and components to help system integrators. So just keep that in mind. A lot of engineers, a lot of companies supply you with the tools that you need to make stuff because they want you to buy stuff and make stuff and sell their product. Here is GrabCAD. It's one of many different kinds of file repositories where people just kind of doodle and upload their files. They have a lot of computer parts on this site that you can download and use. However, I can't stress enough that you should never, ever, ever rely on these models if you're going to go get your stuff made, particularly in a manufacturing scenario, because a lot of the models are wrong. The holes won't line up correctly, and you'll end up wasting a ton of money on a prototype. But it's great for just getting the rough dimensions of parts out there and getting started. Oops, 120. That's not going to work. But as you can see, I typed in 120mm fan, and we see lots of different computer type case fans. If I type in graphics card, start to see lots of different graphics cards. But again, don't trust these when you're making mounts and stuff for it in your computer case. You could end up getting burned pretty badly. And then finally, I have my Patreon. I'm plugging myself here. Sorry about that. But I do have case files, and I do have parts, and I'm trying to update it regularly with stuff that I make. All the cases from my projects and stuff I put up on Patreon. So if that interests you, now you know about it. But again, this project will be available to YouTube. Alright, so I'm going to get started here. I'm going to look for my NFC SkySlots die, which I don't know where it is. I'm going to try to use the search function. Cool. So I'm going to put this into my main body. I'm going to hide my PC hardware in this power supply bracket and get this into place where I want it. You're probably wondering, is there a better way to do this? And I'm sure there is. So you may feel free to comment. But this does work for me, so I'm doing it this way. Plus, I also want to show this concept out. Even if the particular thing I'm doing isn't what I want to do. I actually want my SkySlots going forward to the front of the case, so I'm going to rotate this around. SkySlots is just the trademarked name. They are trademarked of the event pattern that NFC has developed, with a lot of resources going into them, but they are extremely cost efficient to laser cut, which is very important because if you add a lot of different little cuts for like vents and stuff, it can really add up. I mean, your cost of your case will explode. Secondly, it's an extremely strong pattern. So once you get the cutouts, you can have a lot of area for flow, but your panel's not going to warp or bend. And then finally, that has excellent EMI capabilities for containing EMI, given the huge cutouts. So depending on what hardware you're running, it may not be enough for you, but we were able to use it to pass FCC testing on several cases using SkySlots. And finally, they are VESA compatible when spread out in an array. So those are all the features of SkySlots, and of course you can use them for your own projects, for your personal use, for absolutely for free. Or if you're an engineer at your company and you just need something made for your company, inside your company, that's also totally free. Alright, this is about where I want it to look. Maybe right here. Do some slight adjusting later. Now you might ask, well, why don't you just, put up a sketch and then put it in the direct center? And that's a great question. The reason I'm not doing that is because it won't look right if it's in the direct center. Because the case has the little bend, right? It has a little curve with a flange. It has this flat ridge top. And I need it to look centered overall to the human brain when I zoom out, not centered on a particular flat surface or centered to an overall sketch. Plus the sky slots, because of their slant and because of their round edges, they look weird as it is if you put them directly in the middle of a plane. You kind of have to put them up a little bit. I don't know what it is. I guess it's kind of like the Acropolis in Athens where they designed the Parthenon. Is it the Parthenon? With the columns aren't actually in a perfect row. They actually designed them to look like they're in a perfect row when you're standing in front of it. So it's kind of like that. I want that here. Now, I don't need the bottom sky slots. This would be for doing a big array. I'm just going to have one line across, so I'm going to hide these bottom two for right now. And now I'm going to make a pattern and drag it across this face. Before I do that, actually, I'm going to make it this easier on myself. Instead of doing a projection, I'm going to see how thick these are. 2 millimeters. I'm going to make these 2 more millimeters. I've selected 2 bodies from my rectangular pattern. I got to click my direction, which is right here. And now I'm going to just pull it all the way across until it looks about right where I want it. And I'm going to kind of match the top and the bottom. I'm going to move them all a little bit when I'm done. I think this looks fine. So I'm going to say that's fine. Okay, but what I want to do is I want to have the pattern match the spacing of the sky slots, because that matters, right? Especially if I'm claiming that's VESA compatible, it has to keep that same pattern. So what I'm going to do here is I'm going to just start typing in numbers. Till I get close. Oops. Oop. I did this slightly wrong, but the same I'm going to use the exact same process. So now I'm actually matching that second sky slot in the spacing. But I'm going to hit cancel because I forgot I only want to select one of them. But I'm going to do this one more time. Pattern, rectangular pattern, select my direction. Move it out here. And then I'm going to hit 13, which is my number. What? 14. 13. I broke it somehow. Sorry, let's try that again. Sam wants to know if you can, yeah, Sam, you can go ahead and do that. You just have to have a link to the SkySlots file that I have. There's like a terms of use that I'll include in the document. You just have to include that. There'll be instructions. No, not faces. Bodies. Extent. $265. Quantity 14. Don't know what the suppress button does. I want to click it though. It apparently worked fairly okay. So I'm going to unhide this body because I have a duplicate over it, and now I have my pattern. Thanks for the encouragement, Daniel. All right, so now that I have my pattern here, I am going to use it to cut into my case. So I'm going to select all of my visible bodies. And I'm going to, I could do a projection and project all the way through, but I'm just going to actually, I'm going to do this a little bit differently actually now that I'm thinking about it. I could, there's two ways to do this. The first way, which I was going to do, which is not the best way to do this, is I was going to go to modify, and I was going to go to, do I have to select one of these first? Oh, I'm in sheet metal mode. That's my problem here. Modify, and I was going to do combine. And I'll show you what this looks like. So I'm going to select this body. I'm going to move it down through the material. Like so. Click modify, hit combine. I'm going to select the target body, which is my panel. And I'm going to select the tool body, which is my SkySlot, and I'm going to click cut. And I'm using that tool body to cut into my case. And this is really, really useful for making complex cuts. Like you have, let's say, a sphere, and you have a cube, and you can kind of maneuver the sphere on the edges and then subtract that sphere from that cube. Really powerful tool. But I'm actually not going to do it this way because I want to cut through both sides evenly. So I'm going to hit cancel, go back a couple steps right here, and I'm actually going to push-pull intersect through my entire case. I think that's going to be the best method of doing this. So I'm going to hide this really quickly so I can select them. It's so weird how Fusion operates as well, because this is a fine number, but if you have like a lot of surfaces or faces that you're selecting, it can start to really bog down, and each selection takes like 30 seconds to update to the next one. It's horrible sometimes. Hit Q, which is my press pull. I'm going to go back to my cover and unhide it, and now I'm going to just pull all the way through. And I'm going to click Modify Existing Feature. Oops. And it unselected it for me, which is not what I wanted it to do. I might have to end up hitting combine. I don't really know what I'm doing wrong. Sometimes you can hit modify existing feature and then subtract, and then it will just automatically extrude it. But I might have to end up using this as a combine tool. We'll see. Like I said, I'm not a Fusion expert. This is just kind of me working my way through my process. Okay, well, I'm not going to click that again. I don't know why it's not working, but this is fine. This will work perfectly okay. So now I have my sky slots going all the way through my case, and as we just did before, we're going to hit modify, we're going to hit combine. I'm going to select all my tools. Wait. My target body first, and then my tools. Cool. And then I can do one of two things. I can click keep tools, and then it will just keep them there for future reference. Or if I didn't want them anymore, like I just want to get rid of all those bodies that I created in the pattern, I can just click OK, and they're all going to be deleted, which I'm fine with. I can always add the sky slot pattern back in later, and I don't want all these bodies just floating around. So I'm going to hit OK. It's going to do its thing. Matthew asked a great question, and he asked why I use bodies rather than a sketch for cutout features. You know, when I'm designing a computer case for production, generally it's better to do things all in the sketch, because the manufacturers aren't really going to look at the 3D so much as they are going to look at the 2D CAD, and that's kind of easier to share and go back and make changes to. However, I find that process to be very tedious and very slow, and for quickly designing a computer case, I think this process works totally fine. There are some things that I do sketches for, which I'm probably going to end up doing later in this this video, but I just wanted to use it the bodies way. Also, I want to also add that Fusion is really slow when it comes to working with sketches, and then because Fusion wants to keep in memory, I guess, or I don't really know, I'm not going to act like I know, but Fusion is constantly recognizing the fact that you have something in a sketch and it's pulling from that sketch, so it's slow. It works really, really slow. Whereas if you do it with bodies, it's like you cut out the body and then it's like, okay, fine, there's a 3D model sitting in front of me, so the performance is actually pretty good. Now, that's not really good reason if you're designing a case professionally, but for my purposes here, I'd prefer the extra performance for these simple operations. Eric, NFC Eric, who is the CAD master, he only makes things in sketches, one part at a time. But you can't teach an old dog new tricks, so here we are. Alright, so now I have my sky slots on the sides, and I actually like how these look. I could move them over towards the rear a little bit, but I'm not going to. I really like how that looks. As I was explaining earlier, I don't want to make a sketch and put them in the direct center line because it won't look right. I have to take in consideration the fact that there's these bends here, and the human brain wants to look at this overall and see if it looks right. And it looks pretty right to me. I might do some micro adjustments later, but no sense wasting more time on the stream for that. I don't think I want sky slots all in my front yet. I'm not entirely sure, so I'm not going to make them quite yet. However, I do know that I want to see that beautiful graphics card, and Sapphire is going to want to see it too. So we have our PC hardware on this side. I'm going to expose it on the back side. I could put an array of sky slots to see the fans in the back, and that could actually look pretty cool. It may be what I want to do, or maybe I want to make a full-fledged window and do some kind of border around it. Maybe like cut out of MDF or something, and like a spacer that pushes us more towards the graphics card, so it kind of looks thicker and beefier. Let's try that first. I don't know if that's what I want to do. So what I'm going to do now, and this is also probably bad practice, but this is just how I do it. So if you're an expert, feel free to ignore. But I'm going to, at this point, duplicate my cover and my tray. And I'm going to start experimenting now. And I don't want to mess up the old one. I can always go back on the old one, but I just find it's better to duplicate it and just delete it if I absolutely hate it. Or if I kind of liked it and I wanted to see what it looked like versus the old one, then I can just hide it. And one more thing too, in case we missed this in the previous stream, my process for designing a case is I have this messy table approach where I put everything into my document to start with. I experiment, I move stuff around, and Fusion's going to get really bogged down because that's not how Fusion wants to operate. But once I have everything how I want it, then I'll start exporting the pieces one at a time into separate folders, and then I'll do an assembly file, and I'll use joints to put everything together, and then I'll have a very high performance 3D model that I know aligns properly. But this is kind of my Messi's sketch table. Hello, my Russian friend. I'm sorry that the minis are not shipping to Russia right now. I really wish that they were. So, hopefully they will be soon. SMU says, looks like the Silverstone Raven layout. Yeah, it is like the Silverstone Raven layout. But the Silverstone Raven layout is really like the S3 Mini layout, considering it came out 3 years before the Silverstone Raven. So I don't feel too bad about using the layout. Okay, so let's make this, duplicate this, right click, I'm gonna hit, there should be a duplicate button actually. I don't understand Fusion, why sometimes it will have options and sometimes it won't. But copying this is fine, I suppose. So I'm going to hit right click. Copy. I don't see a duplicate. But I'm going to right click and I'm going to click paste new. If I hit paste, any changes I make to the thing I pasted is going to update the other piece. So that's for like if you're trying to create the same part, like multiple parts, like the stand of a table, 4 legs, you'd hit paste, and that way you'd have your 4 legs, and you could just work on one leg, and all the other legs would update automatically. But I don't want that, so I'm going to hit paste new. And that's a fine name for it right now. I don't really care. And then I'm going to do the same thing, copy. Oops, did I hit cut? Copy. So I'm going to hide my original tray and cover, and now I just have my new tray and cover. Hide the cover. I'm going to reduce the opacity of my tray. And I'm going to make a cutout on my back. And I'm going to use a sketch for this, because I think this is faster than using a new body. I don't want to go over the entire graphics card, because then when you're standing over it or to the side of it or somehow underneath it, then there'll be a gap in the case, right? And that will look bad. So I'm actually going to make it less wide than I think that it needs to be. So when you're standing over it or below it or beside it, you actually see the whole card, or most of the whole card. It'll look cooler this way. So I'm going to make this... Actually, I have an idea. I'm going to use the cover as a guide for back to front. And I'll just make it shorter. I think that's right there, right? Yeah. No. That can't be right. That was the flange. What was I thinking? So where's the cutout in the front? Do I need to make the opacity of this lower? It's down there. I wish it would update. Now that I have this in place, I'm trying to think if I like it or not. Of course, I'd round the edges. I'm going to put a window over it. But I feel like if I go expose the card more on this side, then I'll get less case, which I don't know if I really want to do that. So I don't really know if I like that so much. So I might end up using sky slots and go with the Sapphire RGB fans that plug into this graphics card and do some LED lighting to illuminate the card from that side. I could put some circular cutouts for the fans and then use spacers. I could try that too. That could also look pretty okay. Could also look really weird. Let's see what that looks like. I have to confirm my graphics card that the fan hub centers are going to be the same, which I think that they are. It's going to be 60 millimeters for the first fan hub. That looks about right. And then fan hub to fan hub. $98. And fan hub to the last fan hub. $98. That's kind of interesting. So this graphics card, which is the 5800 Nitro Plus, has the same fan spacing and fans as the 6800 XT. So let's try it. Let's see what it looks like. We're just experimenting. My background, again, is actual level design. So Unreal Engine, Hammer, Radiant, that kind of thing. So it's more of a, once you get the system in place, I just do a lot of experimenting. This might grind on a lot of engineers on how I do this, but this is how I do it, and that's all I can show on a stream. I don't want to go all the way, or do I, and use 3D printed parts to kind of suck it in there. Yeah, I think I'll go a little bit over in that case. I'll do 88 for this one, maybe 80, maybe 90. That doesn't give me a lot of room for the other one. I'll go 88. 95. I want to move this one so it's in the same plane. I want to move a copy. Hit create copy. This is going to show a lot of case and not a lot of card now. It's kind of the catch of 22. But it could look pretty cool though if we do get the Sapphire RGB fans. Answering a couple questions. Gabe, this is going to be 3D printable. However, it will be able to be made by you through companies like SendCut Send. So you can go get the case made yourself. And thank you, Gabriel, for saying hi. So, hello. I'm going to kind of just roll with this for right now. I don't know if it's what I want to do, but I'm going to give it a shot. I made a big error in Fusion. I made my sketch on my main document instead of my new tray. I'm going to keep that for now because I'm going to go back and redo it so I don't have to waste time on stream, but you're supposed to select the component that you actually are working on so the design history is neatly contained on that component rather than the whole sketch. So that was my bad there. So if you're going to be doing this for your own graphics card, you'd probably want to use an array of the sky slots instead. That's what I would recommend because this is only going to work for this very particular GPU, which is the point of why I'm making this case anyway, so it's going to be okay. Now with it full opacity, I see that the case is kind of a little front heavy now because the card has to sit this far back. Do I hate it? A little bit. I think I can get away with bringing the front in a little bit more. So I'm going to kind of cheat and do this because I think I can get the card installed because of the really cool 3D printable bracket that's going to hold the card in, which is you can see in the previous video. So I think I have room to play with here. So I'm going to come down here. It looks like I have about 10 millimeters to safely get the card in. So let's see what that looks like. Again, I have the tray selected, which is what I want. Hit move. And I'm going to come back in 10 millimeters. Which I can fit, but boy, is that tight. That means I'll have to install the card by this view right here, sliding it in that way. That'll be kind of difficult to do, so I don't want to go that far. So I'm just going to go 5 millimeters. Oops, that's 15. Because something to keep in mind is that I have the flange of the graphics card, right? So that flange means I have to at least account for that depth if I wanted to cleanly install it with the flange. However, I could get this graphics card in, I think, by angling it into the computer case. And because of this clamshell design, that front clam is going to open a little bit. So I think I could spread it enough to get the graphics card in. However, it's not ideal for a case that you'd be designing. Again, I would keep that extra space. It's just I'm trying to see if it looks okay with the fans. And I think it looks a lot better now this way. So I'm going to keep it. I'll provide all the information that you need in the description later, so don't worry if I say something like SynCutSyn and you didn't catch it. Just don't worry about that. And I'm also going to go through the process of showing you how I get it made. So T says, where can I download the motherboard, GPU, power supply models from Fusion 360? Well, you have to make them, really is the best way to do it. But again, there are repositories like GrabCAD, but you don't want to rely on those because they could be inaccurate and you could get a bad case. And you also have like my Patreon. If you go to my Patreon page, which is /NFC, I have a lot of these models available. This particular model will be available after the live stream is finished sometime. Jesse, you're more than welcome. I'm sorry that my process and my thinking is so slow and unprofessional, but I figured I might as well show it anyway. So maybe it can help somebody. Because if I can do it, anybody can do it. And that is the truth. I don't know. What do you guys think? Do you think that the cutouts of the fan are going to work? We put some trim over it. It's just a little bit too gamery. I do want it to be a little bit gamery because this is a case for Sapphire to show off their stuff. It's going to be a custom mod for them. So it can be a little bit less tasteful, I guess is the term. Usually when you're making a case for everybody, you want to tone everything down and make it minimalistic so it appeals to everybody. But it can be a little bit wild and crazy for this. I just don't want to be too... I don't want to be ugly. Okay, for the motherboard, do I want to make any more cutouts? Make some sky slots for everything? I think I could. I think I should add at least the mounting points for the motherboard, though. Maybe the power supply, so I know that if I'm making sky slots, it's going to look okay. But then again, maybe what I'll do instead is I'll do a cutout of the Nitro guy. Really big. I could do a decal of the Nitro guy. That would kind of look neat. Or maybe I could do a cutout and then put a piece of acrylic behind it. As long as it's going to look good from the top. Because that is a consideration that I want to make. Either way, though, I know that I want to have some kind of acrylic or spacer in front of the graphics card. So I'm going to make that part right now. So I'm going to make a new component by clicking my top component. Create new component. It's going to be a standard component because I'm going to laser cut this out of acrylic or 3D print it. I'm not going to do sheet metal for it. And we're going to call this fan spacer. GPU fan spacer. And I'm going to create just a box. If I click the planar face, it's probably going to want to merge with it, so I'm not going to do that. I'm going to click outside of my model and just move it. All right, I've clicked outside my model. Now I think I can place it inside right here. So here to there. I think that's correct. Yep. Cool. So we can just start adjusting my box. I want to go this way. I want to mate up. 10 millimeter. That's about right. We want to make sure that it covers my fans in the front. This is on the bottom flange, so we have no problem going all the way to that edge. Now I want to make sure that it's somewhat centered on the graphics card. I actually kind of like it a little bit below. And we'll come up just above it because this is 110. Let's make it 115. Okay. Now, I don't usually do appearances this early on, but instead of changing the opacity, I know I want to make it out of acrylic. So I'm going to go down to plastic, and I'm going to go down to transparent, and I'm going to, that's kind of cool. I do have orange. I'm not going to use orange though, but I'm going to probably use a blue or something. Maybe a dark gray. Something that kind of catches. I do have a blue, but I don't want to do blue. I'm so bored of doing blue. I'll do a clear. I'm actually going to do a red for the model and come back and make a change later. I'm going to change this red to a purple for right now because I like purple and I want to make a purple case, although I can't get acrylic thick enough in the purple. So now I just have a color in my brain that I'm working with, so not everything is so gray everywhere, because I want to see how it looks when I cut it out. Okay, I can do a couple things here. I can leave a slight ring, but I kind of already am up against my upper parameters with the sheet metal, so I don't think I'll do that. Maybe it's the slightest possible ring, so it will catch the lighting. Maybe I'll do a chamfer operation with the CNC instead of laser cutting this out. Let's try that. I think that will look kind of cool. So I'm gonna use a hole feature this time instead of a sketch. And the reason is I can click my acrylic part anywhere I want to, as long as it's the part I'm cutting into. I'm going to choose what I want, simple hole, simple right here, so we don't have to specify any bolts or anything like that. And we're not drilling into it like a drill, it's just gonna be flat. We're just making a standard flat hole. And we know that this is going to be, first of all, we wanna center it. This is what's cool about the hole feature. We can click any circle reference that we want. Boom. And the hole now centers this cut that we're making. Really easy, really simple. Was so funny, guys. I used Fusion for like 2 years, I think, before I discovered the hole feature. I was making sketches with holes and then going and extruding them all by hand. And I didn't know that you could use the hole feature, which is absolutely epic. And you can choose what screw sizes you want. I'll show you more later. That's going to be important. Really, really awesome tool. So the diameter, we know this is going to be just 10 millimeters thick, 10 millimeters deep, rather, the cut. And 100, was it 95? Let's just look. 95, 94, 93, 92. What's 90 look like? All right, I'm gonna make this 90 because I want a little bit of the acrylic showing on this side. And again, we're gonna do a chamfer. I think when the LEDs hit it, it will look really neat. So I'm gonna double check and make sure that I'm not cutting through my model. I'm not. It's being a good boy. So press OK. Hole number 1 done. Let's do number 2. Same thing. Click on my plastic. Click on my outer ring. Do this one more time. There we go. Click on my outer ring. And then I'm going to adjust this from 90 to 85. Is that about the same? It's close. It needs to be a little bit less. I'm going to move it up to 83. Now, something to know about fans, which I'm sure you guys already know, most of the power of a fan, as far as the how much air it can push, the pressure, is at the very edges of the blades. So we do want to have, we kind of want to cover that just a little bit, but we still want to leave the edges of the blades open to the air, because let me see if I can rephrase this. All the power of this fan is going to be in the edges, pushing down to the GPU's fins. So the air is going to get sucked in towards the middle, but slung out down towards the edge of the fan. So if this was reversed on the other side, this would be a horrible design, because this little ring that we have here would be blocking most of the fan's ability to generate pressure. But since we're sucking in air past it, and it's going to be pushed down into the fins, this would be okay. I'm really sorry that I'm a bad teacher, and even worse at explaining things, but hopefully that makes a little bit of sense. Sorry, I got my... Oh, that's the depth. I definitely don't want that. Let me turn off that notification. And go back to the questions. So now if you're looking at it from the top or the bottom, or kind of like the side, like in real life, I'm going to click perspective view. We can kind of see this big chunky kind of carburetor spacer going on instead of this ugly gap where the card is kind of floating in front of the case panel. Does that kind of make sense there? I think it kind of makes sense. So I think it's going to look a lot better, especially when we have the LEDs going. It's going to look really cool. Now you can see that we have the outline, and that's because in 3D applications, every 3D application I've ever used, if you have two 3D models touching each other exactly, it will cause weird rendering errors. So the solution to that is simply to move it out a teeny tiny little bit. We're actually going to make this 0.5. So our rendering error is gone, and more importantly, when we actually go to render this, it's not going to make a weird flickering error. All right, going back to design. Blake says, how do I like Fusion? I love it. It's absolutely game-changing and allows my business to actually operate and work. It's incredible. Absolutely incredible. I started off with, like I said before, I was a more graphics designer type of person, not using CAD, right? So CAD was difficult for me to learn. I started learning Inventor, which is very complicated. I used a little bit of SolidWorks, which I liked a lot better, but super expensive. I couldn't afford it. So Fusion was free, and it is free to use right now, just for doodling. And for my company, it's like $500 a year, which is a stupid good price. And you get so many different tools, like the manufacturing tool, so I can actually put this on my CNC and get this made. Whereas the other software I was using didn't have that. You had to use other software on top of it. So I love Fusion. It's a great, great, great product. Okay, So now I have the outside, and I kind of like where this is going. It's a little bit gamery, like I said before, but that's kind of what I'm going for. This is a mod to show off a graphics card. So I do kind of want it to be wild and unique, kind of like a lowrider type of look. Again, you'll have the files for this. You could edit yourself if you don't like something I did. And I have other versions of this computer case, if I can pull it up, on my Patreon. Lots of different versions already made, ready for you to go. I just work from there. So if you don't like what I'm doing here, totally understand and respect that, but there's lots of different versions that I'm making. So let's do the back side now. We won't worry about mounting just quite yet. That's not so important to me. But we do want to make this a little bit prettier. For one, .581. .4. I'm going to reduce this because we don't need it. Save some plastic. I don't know what happened there because I had it selected. About 4 millimeters this way. It's about right. The only thing is if I look at it from this angle, I do want a little bit deeper. As long as it's about 5 millimeters though, I'm going to be happy with it. Oops, sorry, I just bumped the microphone with my hair. T's asking how I add a model to a project. I'm sure I'm going to be doing that quite soon. I've done it many times so far, and I don't think I'm over with that. Kenneth asks if this will be recorded later. Yeah, it will be. It's recording right now, I think, but it's definitely going to be saved on YouTube. Yeah, I'm recording it, and so hopefully somebody also will come back and volunteer and chop this down to size. Protato all has pretty good facts right there. You can cut aluminum with a laser. In fact, SynCut Send has lasers, has fiber lasers, and I will be cutting this out of aluminum with a fiber laser. But yeah, my laser, my metal cutting laser, I can't cut aluminum. I can only cut steel. I'm actually going to keep the thickness up and down, even though that could save me a little bit of money on acrylic, because I want that depth. It's a computer case, right? So I'm going to be looking at it from kind of like the top, and I don't want it to be so thin that I peer through the other side of the acrylic. I want it to be super deep. So this, I probably could pull it up a little bit, but I'm not too worried about it. I'm going to leave it as it is. Other than weight. Weight savings actually would be a concern, but not that big of a deal for this particular mod. It's not a production case after all, just one that we're going to make for a mod. Now, I usually save my chamfers until I'm completely done with the part, because I might want to go back and edit the part later, and I don't want to deal with a bunch of chamfers everywhere in the design history. But I'm pretty much done with this part. The only thing I'm going to do is I'm going to add mounting for it, and I'm not going to add screws for the mount. I know that for a fact. I don't want screws on the back. It will look ugly. I already have to have screws for the motherboard. I don't know what I'm going to do about that. I might glue some carbon fiber and then mount it from there. I don't know quite yet. It's interesting to think about. But I know that I don't want them over by the fan. So I'm probably going to end up gluing this part in. so I don't have to worry about where my screws are going to go. I'm going to go ahead and chamfer this part. I'm pretty sure that it's pretty much done. So I'm going to hit my chamfer tool, and I'm going to select my edges. Now, something I see people do all the time when they're designing computer cases, and this also includes professional computer cases like from Thermaltake or Silverstone or whatever, and a lot of Chinese cases, is that they don't stick with a look for their chamfers. They kind of just use different sizes everywhere. Now, you can obviously have them different sizes as long as they look similar, but you want to keep it looking similar throughout the case. You want your case to have a certain aesthetic to it, and it just looks bad if some of your chamfers look like this and some of them look like this, you know? I want a little bit smoother, rounder for this look of this computer case. Not too much. I'm going to keep this at 15. I'm going to try to keep this look for any rounded parts I do throughout the case. But if you want to know what when I look at a computer case and I see different kinds of ventilation cutouts, oh, that's ugly to me. That's really ugly to me. Or I see them using different kinds of bins throughout the case, that's ugly to me. And now I'm going to chamfer these. Decide I'm going to do this on the CNC. Plus the CNC will give a much better edge than the laser. It will make a nice smooth edge that I can polish out really well. And we're going to drag it a little bit. Oh, I don't want to fill it. I actually do want an actual real life chamfer. Two millimeters. I think that is going to look really slick on the CNC. All right, one little fancy trim part down. Now we have to figure out what I want to do for the motherboard, because the motherboard, I was planning on actually just putting bolts right through to bolt to the tray. And I can still do that, but it will kind of look ugly, right, with 4 little bolt holes down there. I could use custom 3D printed standoffs, though, and put something behind it and glue up the part down precisely. The question is, how will I know where to put those particular holes? I could, on the CNC, if I was going to make this on CNC, mark those holes really easily, so I'd know exactly where to place my motherboard. I think in this particular instance, it's going to be better looking and better served if I do some kind of trim plate on this side, either out of carbon fiber or an opaque acrylic, maybe a piece of aluminum. That way I can just cover up my holes. It adds the cost of the computer case, but I'm not worried about that because it's a mod. So let's put my holes in right now, either way, for the motherboard, and then I can worry about covering them up or deleting them later if I go a different route. So to make those holes for the motherboard, I'm going to press H for my hole button, capture the position, click my tray. Definitely don't want that this big. Blah, 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 blah. Because I'm actually doing this for a screw, I'm going to click clearance. And because I'm going to make it countersunk, I'm definitely going to click the countersunk button as well. Well, actually, I'm going to show you countersunk, but I'm not going to do it for making this computer case, and I'll tell you why in a second. And then for the drill point, we want it flat. The depth, obviously we want the thickness of the material, which is 2. And we're going to choose an M3 screw. And now Fusion knows exactly how thick, or it knows what the diameter of this screw hole needs to be for an M3 screw, a clearance M3 screw. Now I clicked the wrong side for the countersink. That's fine because I'm going to redo this in a second anyways. But it would automatically show you what the countersink looks like as well. See? And then if you're doing the cam inside of Fusion, you can set it up to do a drill operation with your countersink, and you'll get this nice countersink hole. Really cool, really clever. We don't want to use the countersink though, because I'm going to add the countersinks manually with a hand drill when I'm done, because I'm sending this off to a laser to get cut. And the laser can only make 2D cuts. It can't make the countersink, and it will confuse the software or the engineer operating the software if I have this countersink here. So I'm actually going to click undo and redo this. Now, I'm not going to use a countersink. I'm going to use a simple hole, M3. So that's important, guys. If you're going to be sending this off to SendCut Send, don't use countersinks anywhere, because SendCut Send is not going to do countersinks. You're going to have to add them yourself, and you don't want to confuse the software. All right, now I have my hole, and this is why I love the hole feature so much in Fusion. I don't have to drag it or position it or move it around. All I have to do is click where I want it to be centered, and Fusion automatically will put it centered on the hole that I clicked. Boom. So now I have a motherboard hole exactly where it needs to be. And I'm going to do the same thing a couple more times. Something else that's kind of cool, if you are if you do a sketch with your sketch, and if you make all your holes in a sketch, you can click the hole tool, and then you can click one button on the hole tool with your sketch if you're referencing a sketch, and it will automatically put holes in every single size, similar sized sketch objects, if that makes sense. Very handy. So you have to click every single hole on your sketch. You just have to click one. Sam asks if there's a service I recommend. Yes, it's SendCut Send. Don't worry though, I'll have all this information, and we're actually going to do this later in the stream. I'm going to show you how to get this case made on this stream today. But countersinking you'd want to do yourself. You don't want to pay a company to do countersinking for you if you're doing a one-off, because a one-off prototype, I mean, it's going to be hundreds and hundreds of dollars if you want them to do everything. But with SendCut Send, you can get these panels made for, we're going to find out how much it's going to cost, right? And then you can pay them to do the bending if you can't do the bending. I'll talk about bending strategies later. And then that's all you have to pay them for. And then you can go back with your hand drill and make all these countersinks. And of course, follow my normal channel where I do like short form videos, and I do all this stuff all the time, and you can check out how I end up doing it. Generally speaking, though, I do make these myself, that's correct, but I want to demonstrate SendCut Send today because a lot of you don't have tools, right, to get this done. So you want to just send this off and then get your case back. So now I know exactly where my motherboard holes are going to be, and I can plan on how I'm going to cover them up or integrate them into the design. Something I do know is that I'm going to have 3 holes on the top here and 3 holes on the bottom here. I gotta go sign for a package, guys. I'll be right back. Sorry. Sorry about that. Right, screws. I want to have screws on the top here to fasten the top. So I know I'm going to have screws anyway on the back of my case. But as long as they're in a nice pattern, it kind of looks good. But when they're kind of everywhere, it's not going to. But I have a problem, and that's I can't really make a cover to cover these two bottom motherboard screws up because that's going to cover where my other screws are going to bolt. It will look kind of weird, I think. So I think the way to tackle this will be with a pattern of some kind, maybe sky slots, to make my brain feel like those holes really aren't there. I don't want to put sky slots behind the power supply though. That would be dumb. And I don't want to put them... I could put them behind the motherboard right here. Give us kind of access to the back in case we wanted to put like another SSD there later or something. I think I have to add my screw holes to my clamshell design now in order to get the look I'm going for. I usually like to wait as long as possible before adding holes, but I'm going to have to. I think I'm going to have to do that. And the reason I like to wait is I don't know how I want this to look yet, right? And I might end up scrapping this look for another. I don't have to go through all the work of adding the holes all over again. But it's important at this point, at least, to do these ones so I can see how it's going to go together. So let's do that. Let's see, this one's going to be the pass-through hole, check. And the mating one will be the countersunk hole, the tapped hole. I'm going to use now a reference. I used the reference before, it was the circle, right? Put it right in the center. But now I'm going to do the reference from this edge. I want it to end up somewhat in the center of my flange. Five is pretty good. I'm going to keep it at 5. We make it 2 millimeters. And of course we want this centered, so I'm going to find out, I have to go back and edit it. I want to find out how long this little part is. 310, half of that is 155-ish. No, it's 0.975. So I'm going to, oh, see, I already made a mistake. So I'm going to, I have the fan spacer selected. I want to make sure that I have the tray selected. $155. So now it's mostly centered. 5 and 155. All right, to the other ones. And we'll say 20. What's 20 look like? And here is 5. That's good. I don't want it totally on the edge. I'm fine with that look. And it's going to hold fine right there, so functional and cosmetic. I must have selected the wrong part. What is going on? The phantom hole. Let's try this one more time. Where are you going? Oh, wait. Let's make sure that I'm here. I don't know why it's doing that. It's not even giving me an error. Can I do it anywhere else? Very strange. And we definitely do want to know exactly where it is, so I can't just freehand it because we have to make mating holes. Might have to restart Fusion. Okay, I don't know why it decided it wanted to start working, but I'm fine with that. And I'm going to do the bottom now. So now I can see where my holes are going to be. And again, I'm not happy with the fact that we have the motherboard holes. The other ones are fine, but the motherboard holes just look kind of bad. So, is it a big deal? The biggest deal in the world? No, but we can do a little bit better. I just need to figure out how I'm going to get them marked accurately when I send them off to the laser. And to do that, I'm going to have to use a reference for the extra part that I'm going to make, so I know exactly where to line it up. And I just have to be creative and figure out what that reference is going to be. I think that reference is going to be some notch or key or some other hole that already has to be here. Oh, I need to do my power supply one. So let's do that. I'm not going to have feet on the bottom side. And because I don't have a hole that to align for my fan spacer, I can't use the top part of that. Basically, my problem is, guys, just to reiterate, I'm thinking of a clean method to cover the holes on the back side of the case so it looks good. I don't want to just slap a cover, a trim cover plate over it quite yet. I might. Maybe I could do like a carbon fiber and then offset it a little bit even more, and then maybe have the Nitro Guy logo cut out of that or something, or do it out of aluminum. I don't know quite yet. Or the other way I can do this is by reducing the standoff height on the motherboard to like 6 millimeters instead of 8, and then using a panel that will glue into this side of the motherboard tray, the case tray, which will have all the studs I need to bolt parts to it. That way I can have a nice clean back. I don't mind doing a cover on the back, it's just that I'm dangerously close to the bolts here, so I don't know how that's going to look. Maybe I could do like a little offset and then use trim bolts, like these M4 washers. I'm gonna go get them and see what they look like. This is what they look like. They're these little cupped anodized washers. You can order them in different colors. Maybe I'll do that. I'll do those for the case screws. Do like an M4 countersink with these trim washers, these cup washers. And then do a trim plate that kind of goes around them. That kind of could look pretty good. I'm cold again already, so I'm putting my heater on again. Hey Michael, I'm glad that you got your Mini, and I'm glad even more that you love it. So thank you very much for being a customer, and enjoy your Mini. Nazim, this is a computer case that I'm making, a Mini ITX computer case, and I'm showing people how my process of start to finish, making it and getting it made. Probably gonna need a moderator soon. So anybody I know wants to volunteer, let me know. Okay, let's do that. Let's make a trim plate for the back. Since it's going to stand up vertically, it'll be fine. Create. Select my base. It'll be standard. I'm not going to bend it at all, to my knowledge. Jesse asks if I make a case out of aluminum like the LZ7. And one thing that's really important to me as a small business owner and designer is to stay in my niche and not take business away from my friends and other people that are trying to do this, even my enemies. So I'm going to let Kevin with Laser 3D make his case and keep his case and his design, because it takes a lot of work to come up with a good design like that, and I'm not just going to rip him off. Even if I made it look completely different, the design's really the hard part, and he's made his business around it. So I'm going to focus on making new, unique stuff and selling it. That's why, for example, I don't sell this particular case as a manufactured case. Even though this design, I had a design like this before anybody else was using this design years and years and years ago. In 2004, you can probably Google and find it. But now there's like the Dr. Zaber Sentry. He's making his living doing it, so I'm not going to cross into that territory. So that's why I'm not producing a design like this. My rear trim plate. I'm just going to create I could make a sketch and extrude it, but I don't need to. I'm just going to create a box. Make my box anywhere. I think this is what I wanted to do, something like this. We'll say 300, fine. Let's see what that looks like. And 325. Can we do 330? We can. I think that will look actually kind of good the way I have this in my head. Might look a little weird too. We only want this to be at max 2 millimeter. I might even make it out of carbon fiber much thinner, to be honest. Let's say 1 millimeter. Again, I don't want it to be flush because when I go do the render, I don't want there to be any faces that are kind of warping or wobbling back and forth. 3D applications do not like it when you put two faces actually touching each other. I'm actually going to change the appearance on this now. I don't like using different appearances this early on, but I do want to see how my edges are looking. I'm actually going to center this using good old-fashioned measuring tools. That's 8.7, 8.8. 9.5. Oop. So 0.35. I gotta move this. That's basically nothing. Basically nothing, but I'll do it anyway. Now I'm going to do these little trim cuts to go around the M4 washers, but first I got to make sure those M4 washers are going to like fit on there. So I'm actually going to make a new component and call it hardware for modeling the screws later. Think of a component kind of like a folder, kind of, well, it's not really at all like that, but you can use them. I use them like that. We'll call this hardware, or fasteners rather. I'm actually going to make my little washer now. Where did it run off to? Hello, Anya. I'm working on this stuff too, so I don't always see it immediately. I've been using Fusion, I don't know, since it came out. So whenever it came out. These are 10 millimeters. Oops. And they are 2.3 millimeters thick. They have a hole in them for an M4 screw, 4.3. We can actually come down here and select M4, which they have a 4.5, so we're not going to use that. We're actually going to use the actual washer, make it as accurate as possible. So we're just going to click simple, and we're going to say 4.3 because that's what our actual washer is. And I'm also going to make it countersunk. Oops, I should probably modify that a little bit. And that's about right. That's how it looks in real life. And we're going to throw on an appearance. Get them in black. Now I have my M4 washer. And later I'm going to use joints to apply these, but for right now I'm going to do point to point in my draft model. Now notice that again I used an M3 screw here. I still might use M3 screws, I might use M3 washers. That's fine. I just know I have an M4 washer and I can go back and change all my holes really quickly if I need to. So I'm not concerned about that. And I think I would use an M3 washer because it wouldn't be so close to the edge as well. But it's not going to look so bad because remember we have this cover. So it's going to blend together a lot better in real life. I'm going to make a pattern with this. If I can make a pattern with the component, I think I might be able to. Yeah, I can. It's usually pretty smart about seeing a hole or something like that and extending to it. Obviously, we're kind of off here a little tiny bit. So let's see if we can... No, 9.5. And this hole's off because I put it in the center from the back instead of from the side as well. But I think I can move this inside the pattern. And I'm going to move this down. And we only want 2. If you select an item in Fusion, see how it little underlines it with a little squiggly line? I just learned that recently. So, yeah. I know I want to select this washer. And this one is this one. Again, you'd want to use joints for this, but what I'm doing now is I'm using a rough draft model. I'm throwing everything in there. I'm throwing all my ideas out here. I'm making changes. I'm deleting things. I'm going to be deleting things. So I make a rough draft, really nasty, slow model, and then what I like of it, I'll export into a folder, individual parts or components, and then I'll make an assembly file and use joints to put everything together at the end. I think I can modify that without moving anything else. Yeah, I can. New again, this is not a new S4. This is just a computer case that I am designing for a mod for Sapphire. I call this idea, this concept, the O5L, and it's an open source design I've come up with that's easy to design. You can download different variants on my Patreon channel, and this particular model will be available to YouTube when I finish this live stream. So, all right, now as you can see, my little trim cover plate is intersecting with the M4 washers I just made, but I can't really make my trim plate that much smaller because, as you see right here, I have the motherboard screw holes really getting close, and I want to cover those up. So what I'm going to do instead, which I think will kind of look interesting, is I'm going to I'll just show you. I'll just show you what I'm going to do. I'm going to make a new component or a new body. I'm going to make a new body, and I'm going to delete the body when I'm done. Where's my trim plate? I'll do it under the trim plate. Create cylinder, capture the position, put it outside my model, see if I can find a reference hole to start. Might just have to align it later. But I'm going to try to do the first one somewhat in the center here. I'm going to do this. And I want it to be, well, it needs to be at least 1 millimeter to cut through. Now, that's fine with me. And I'm going to move this body that I just made. Move it point to point, select my circle, and then I want to move it over this hole. Totally flush. Okay. I'm also going to make it a little bit taller. And I'm going to make copies, and instead of a pattern, and put them over the other holes so they're exactly over those other holes. Because they're round, I can select the edges, which is really nice. Now I'm going to use them as dies to combine through my trim plate, and then they'll just disappear and I don't have to worry about them again. Hit combine, hit my target body, hit my tool bodies. That's the wrong body. I don't want to keep my tools. I want them to go away forever when I'm done. Hey, Mr. Chauffeur, I definitely have made feet for the Mini using the CNC, and Eric has a new design, a stand coming for the CNC, which he is or a new stand for the Mini, which he's making. It's a really cool design that I think is worthy of NFC systems, but it's clever. It's very clever, and he'll be showing it off soon. All right, so I have my little fasteners. That looks a lot better. It is not exactly how I had it planned, but I'm gonna do this now and see what it looks like. So first I'm gonna go through the outside edges, select my corners. Five looks about right. And then I'm going to do all these cups, the edges on these cups. Of which there are 12 of to zoom in and out of. I'm concerned about the outside edge one, right? Because I want to align with the other I just did. I don't think I can make it 5 millimeters, but I'm going to see if I can. I think that looks fine, so I'm going to keep it there. So now I have a trim plate that is covering all the nasty holes for mounting my motherboard and power supply and anything else that I want to mount on the inside. But of course, I have to put some extra holes in here for our fans that we have. And this will be quite easy. Let's make a hole. Select my trim plate. We want it to be just 1 millimeter deep. We want it to be simple, 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 and we're going to align it with this hole. And we want it to be, let's experiment. Let's say 95 to start. 95. Do we want to show off another ring around the paint, or we want to cover the material precisely until it melds into the acrylic? Let's see what 95 millimeters looks like. I must have selected the wrong thing because absolutely nothing happened. Rear trim plate is selected. I'm going to Had a problem like this before, so let's... Oh, well, we definitely want it to be simple, don't we? We definitely want this to be 1 millimeter. Okay, now we'll re-show our GPU fan spacer. That kind of looks good. I know it's going to have the other material, aluminum, showing, and I could leave a little rung, but we're getting awfully close to the edge of this material, so I think I'm just going to leave it like we're doing here. And this is going to be 85? No? 86? 87, okay. Barney, let's just not pretend that ever happened. All right? Let's just pretend that never happened. InfoShill asks if I plan to add PC case handle for any of my builds. Yes. Yes, I do. I've been wanting to make handle for the Mini before I even made the Mini, because I'm a huge leather fan. So the question is just how to get it done. Eric's come up with some nice little wing logos that they do 3D print from the Markforged quite well, but I want something that's more CNC-able. And this is just a strap to kind of test it out, but we're working on it. I really, really want a handle or a strap for the Mini. This is the S4T, and exciting news about that, it will be available for ordering in the United States, hopefully the first week of March. It's not an official date yet, but just to kind of give you guys a heads up, it is coming, so. Barney? Yep. Okay. How can we make this more unique? I think putting the Sapphire Nitro Guy logo right here is kind of my next course of action. I think that will look good. Of course, if I do that, I can't get this part made out of carbon fiber. It'll have to be some thin aluminum or something. I'll just have to paint it, which won't be bad. The Nitro Guy has really sharp interior angles, which can't be done on a CNC easily. I'm not going to do it on a CNC, and carbon fiber can't be cut on the laser. So, you know, catch a 22 here. So let's see what the Nitro Guy looks like. I might have my previous build. And if not, we're going to show you how to use decals. Ryan says, how do I deal with dust in the design? Is there just filters or the path of air and pressure tricks? For my case, it's not filters, because filters are necessary. Well, they're not. I don't like filters in general for a consumer PC case. But filters, you have to have a wind tunnel design of air getting sucked in by the fans, right, and being ejected out. So you put filters on the highest pressure point of the case where the fans are, and then the dust gets trapped there in theory, and then you have clean air exiting out the back. But in the Skyreach 4 Mini, it's not how it works. You don't have intake fans. You just have the fans on the graphics card and the CPU. And they're not intake fans. They are blowing air, they're putting pressure down on the components. So it's like it's sucking in vast volumes of dirty air from your room into the case. I've had many customers comment that the Skyreach 4 Mini is the least dusty case that they've ever owned as far as dust accumulation. And a lot of that has to do with the fact that there's so much room for dust to actually escape. It doesn't get trapped on components. I absolutely will say 100% that it's the least dusty computer case in my office, my Skyreach 4 Mini, whereas my server cases or my render cases or my long-term customer builds, they do accumulate dust and I have to go spray them out. So I'm going to see if I can steal the Nitro logo from this somehow. Oh, they might have updated it. I think there's 2 eyes on the robot now. Bummer. Yeah, the product density is a one-off thing. I definitely can make one for you, but I mean, that's a massive amount of work. It's very, very expensive, and you do not want just the case. If you want just the case, you'll go make it yourself. I have the files on the Patreon, but it's an integrated system. You can't just make the case and stuff your own parts into it. Every single piece on that had to fit together. I actually have a Nitro guy right here. I forgot about. Cool. So I'm going to create a sketch and then see if I can move that sketch and extrude from it. So let's create a new sketch. Where do I want it? Rear trim plate. That's fine. Create new sketch. I don't know what I'm doing right here, so bear with me. Figuring out as I go along. I want to project on this. See it projected right here? And then I want to move this. If I can move this, I don't know if I can. Let's finish it and then see if I can move it. Oops. I don't think I can move a projected sketch, which kind of sucks. I already talked to Sapphire about doing this mod with the Toxic card, but that's not what they wanted to do, so it's just so expensive for them that they can't afford to give that card out for a giveaway like this. Okay, what I'm going to do this a little differently. I'm going to just extrude this and then make it a die like I've done before, you know, and then cut it out of my part. We want to make this 3 millimeters. That's fine. There we have the tiny little Nitro guy. Obviously we need to make it bigger, so let's do that. I don't know how big it really needs to be. What do you guys think? Hey Ryan, there's a couple cases like that already, specifically made by my buddies at HDplex. So check them out. They make, I think, the world's best fanless cases. At least for small form factor. There's some other companies that make giant fanless cases. The Mini actually is designed to dissipate heat from the power supply, transfer to the front bezel, but the newest HDplexes are so cool running that it's not really needed anymore, but it does dissipate heat. If you ever hold a Mini, you'll know that it does dissipate heat. Smaller than bigger. I kind of agree, a little bit smaller. Maybe we, I don't think I can move it. Kind of want the same size as that middle fan hole. I don't want to put the sapphire font underneath it. I just want the logo. Yeah, I don't think that big looks good. I think that's about right. I gotta move it to center it now. It's tricky because remember the fan holes aren't actually centered in the case. They're where the fan needs to be. So do I center on the fan holes and have it a little bit weird in other parts of the case? I think the bigger it is, the less awkward that is. So I might end up making it a little bit bigger actually. Because see, the little chin doesn't line up with that bottom hole, but it lines up with that middle hole. So we kind of want to split the difference. So I think I might make it a little bit bigger actually. Even though I kind of like how small it looks, I want to trick the viewer. I think that works a little bit better for my purposes. Now there's something that we could do that'd be pretty cool. We can, of course, cut through this plate, revealing what's underneath. Or we could cut through this plate and actually laser cut these parts out of thicker acrylic and have them kind of stick out a little bit. That would be nice, but the only problem is that, of course, the eyes would be floating, so that would be very difficult to line up. Instead, what I think I'm going to do is I'm going to just cut through, either use the paint, I'm going to use a nice paint job, or I'll put some super reflective foil tape behind it so the logo will be silver when it's cut through. But either way, I'm not going to delete these bodies. I'm going to keep them around just in case I need to put the logo somewhere else on the case. So I'm going to hide my cover. I'm going to hide the tray. And I'm going to combine these. Target body. Tool bodies, cut, 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 cut. And we want to keep the tools. So we'll have a problem again with this floating part. I'll have to remember to keep these little diamonds. So we have another problem as well that I want to cover. So if we're cutting with the laser, these shapes are fine because the laser can get, it's a very small curve, it can kind of get into these corners real well. But a CNC uses like a round bit, right? So we can only have the maximum corner angle to be the profile of that bit, right? So we can't CNC this part anymore. If we want to have that logo be crisp, we have to have it laser cut, which means that we can't make it out of carbon fiber, which is kind of what I wanted to do. So we'll just have to paint it black or something like that in order to have this acute logo. Now, of course, we could just get a logo cut out of vinyl and then stick the logo on top of that and not have it go through. But I think it's going to look cool like this. I'll have to make a note to the Sencut Send, if possible, to collect these two pieces. Otherwise, I'll just have to remake them again. No big deal. I could even make them out of a different color acrylic, make the eyes like a mirror acrylic or something like that. I think that would look kind of nice. I don't think Sapphire would complain about that. So let's see where we're at. Where's our GPU fan spacer and our PC hardware? So our back side of the case looks pretty good. We've accomplished a lot. We have the fasteners there for bolting the panels together. We have covered up all the nasty holes for the motherboard and the power supply and any brackets I want to hold the GPU in place. So it's looking good. Somebody asks, what happens if you use lasers and carbon fiber? Nothing. Carbon fiber is immune to every wavelength of laser cutter that I know of. So you will burn the epoxy, the resin that holds the carbon fiber together. But the lasers, it's gonna hit that the carbon weave and be like, I don't know what to do with this, and just it'll make a big mess and it won't cut through. It's really weird how lasers work. I don't know any of the math or physics or science or optics behind it, all right? But it's weird that certain wavelengths of lasers can cut, for example, my laser. My laser can cut stainless steel, which is a very, very, very hard material, very strong material. But it can't cut aluminum, which is not nearly as hard of a material. My laser also can't cut your hand. It can burn it a little bit, but it can't cut, your hand, which is crazy. Fiber lasers, on the opposite side of things, I don't think that they can cut plastics and wood. Maybe they can, but they're set up for different materials. But they can cut through aluminum, they can cut through copper. So it just depends on the material itself. Like the lasers they use for tattoos are like way higher wattage than what you'd use for cutting metal. It's very strange, very weird. Go look it up. It's fascinating. Oh yeah, I forgot. I have my other nasty problem to solve here, and it looks like I broke my model somehow. Oh, because I moved that panel in. Okay, so let's work on that. Let's work on cleaning up those edges again. So I'm going to hide my fasteners, my spacer, hide my trim plate. Yeah. And I'm going to hide my computer components. And let's work on cleaning up my case model that I broke. And hopefully I can just do that, pull this back into place. It might line up now, which would be really slick if it did. But, oh no, it's not going to work that way because the whole thing's flush. Now, if I wanted to use a front bezel, I want it to be flush like this. And I might want to use a front bezel instead of using just the stock material. But either way, I have to make this flush, so let's try that. Let's inspect this. What's the difference between this and that? 1 millimeter. Okay. Did I move it 10 millimeters back? Does anybody remember? Let's start selecting. Oops, that's the wrong thing entirely. Or was it 5 millimeters? It was 5. Thank you, Thanos. You were right. If there was a prize, you would win it. But there isn't a prize. So, sad face. All right, so this is the look I want if I was just going to use the metal front panel. But if I wanted to use a trim bezel, I'd actually want to make this more flush and cover it. But I like how smooth it looks from that side, so I might not end up doing that. So I'm going to work on the front last. I can come back and trim that up later. The top, I don't know if there's really anything I want to do for the top. Just want those vents there. The bottom I want to make a stand for. Maybe that's next on my agenda, or maybe that's last once I see how everything else looks. Let's work on the top. Now, before we do that, actually, I want to work on some kind of brace system for this graphics card. The back is very beefy. That's going to hold very well. The riser is going to hold it in place a little bit too. But it's a very long card, very heavy card. It's going to be shipped probably somewhere across the ocean, which I guess is good because I want more people to be able to win the computer. But bad because I don't like shipping expensive and custom computer mods that far. We do have our GPU spacer, which is going to be nice because I can put some foam padding, some laser cut, some neoprene, which I think is toxic, by the way, both for your machine, can corrode it, and definitely for you. So if you cut neoprene on a laser, make sure it's super well ventilated. But I can put a neoprene spacer on the edges here, and that'll prevent it from moving into really flexing one direction, but I still want to clamp it down somehow. So I'm going to design a clamp, which should be quite easy as long as my bender can do an S shape. Let's see here. As long as it's long enough, I think my bender can do an S shape. Especially how thin this is going to be as well. Okay, so let's make it. It's going to be a new component. It's going to be a sheet metal component. GPU brace. I'm going to save this. I don't want to make it on that. I'm going to make it here. I'm going to get the riser ribbon. I want to see how far this sticks up. This card is so thick and beefy that the riser actually sits flush with the back plate, which is cool. That means I can cover all this up very easily and still have it function as a nice sag, anti-sag device. It's not really going to sag, it's going to flex. So that means I gotta bolt it down from like right here. And have a cutout for cables. What if I want to cover the power supply too? All with one part. Let's see, does the power supply stick up over the graphics card? Let's look and see. Because that would give me my answer. Looks like it does. Alright, so we'll just have to make two separate covers. Because I don't want to show off all these cable bundles right here, right? I want to cover that up somehow, so I was hoping to be able to cover both. So I'll just make an anti-sag bracket real simple by doing something like this. Make this 80 millimeters. This will be, doesn't need to be 15, we'll make it 12. And this is a sheet metal part, so we're gonna get the flange. $51. We'll say that it's 52 millimeters. And make the flange go this way. We want this on the outside. This is going to be thinner material than 1 millimeter acrylic, but I'm going to have to go back and adjust this a little bit. And we want this to be 12 millimeters. Yes. Now this one we need to make taller. Actually, I'll make it 54 because we want to have some kind of padding clamping it down, some neoprene or something. Clamping it against the other neoprene that we're going to use. And I'm going to make this out of 1.6 millimeter aluminum, not 2, but it's fine. It doesn't matter for how we're going to end up lasering this case out. So if you're wondering about that. I'm actually going to make this a little bit longer than 12. 12 is the flanges everywhere else in my case, so I kind of wanted to keep it consistent. But this is literally going to be clamping this part down. It's going to be unique, so we'll just keep it at 15. And let's move this part around and make it look cool. I think I can bend this part in the bender. It's kind of hard for me to imagine, but I put it in flat, and then I bend it up, no problem. And I flip that around and put that in, and I bend it up. Okay, yeah, I can do this part. Potato asks, is enough space for a 2.5-inch hard drive? Yes, actually the bracket for the power supply that I'm using right here supports that with this graphics card. So with this SFX power supply, you can put two, and you could put, I can make it as deep as you wanted to put as many drives as you wanted to, but remember there's cables on that power supply. But right now it will support two hard drives, two 2.5-inch hard drives, which are not going in this computer case. I'm gonna leave this bracket in just so you guys can use it. But when I get this part, I'm literally gonna saw it off so it's not there anymore. That's my plan for that. Now, if you're just building this case for yourself, you're not going to need this GPU bracket. It's going to be real stiff in there with the riser cable and everything. I'm just concerned about shipping this overseas. So that's why I'm making a decent clamp bracket. And I know for a fact that this part isn't strong enough to hold the graphics card from flopping up and down if I wanted to add another bend right here, which I could do. I could make it go all the way to the front of the case, I suppose. But I want this to be really bolted down good, so I'm not going to do do it that way. All right, it's where I want it to be, so let's hide pretty much everything else. Go to town on this guy. So the first thing I want to do is I want to add some kind of vent here. Can I add sky slots? That would be kind of dope. I could add the Nitro Guy logo. Let's do that. More of those the better, right? They look cool in the photographs for the build log. So I put that on the rear trim plate. We're going to copy this. I don't know why it's making that sound. I want to paste it into here. I don't want to paste it into there, actually. I want to paste it into here, because it's a sheet metal part. And this should show up under bodies. Yep. So I click paste or paste new. I'm gonna hit cancel. Undo. I didn't have an option. I guess this is a body, not a component. It doesn't care. Just create another dumb copy. Well, maybe let me do minus 0.5. Cannot scale backwards? That's how you do it. Of course, when I cut this through, the eyes are going to disappear. That'll be fine, just for my own fun anyway. I could put the NFC logo in. What kind of glue do you use to bond aluminum and acrylic? Oh man, there's a ton of different glues. I probably would just try E6000 to start with. You can find it at any grocery store. Walmart. It's easy to work with. It doesn't crack acrylic. That's kind of important. Now, is this far enough away from my bins? It is. So now I can combine this, modify, combine, capture my position, target body, then my target components. And I'm actually going to select the eyes too. Well, I'll delete those later because I don't think the computer is going to know about these. Oops, what did I do wrong here? Oh wait, I know what I did wrong. Now, I'm going to test something out right now. I'm going to go to this brace. Sheet metal. See if it errors out. Nope, it did a good job. It realized that it couldn't keep those floating parts. I'll talk more about that later when we get into it, but we're fine for right now. I'm actually don't need to make it this thick. I might make it a little bit thinner. Solid. Go back over here. I think it's bad design for a product designer to make a logo that has floating points. That's why my logo is designed to not have floating points. That way you can always laser it out of something if you want to. But that's just me. Don't want to criticize someone else's work, but logos are kind of important to get right. Add some tasty fillets. A fillet of fillet. Hmm. Five looks a little too round, although I've been using it throughout the case. Let's bump it down to 4 for right now. I'll go back when I do the fillets for the actual sheet metal and see what that looks like. And we're going to need to add, of course, 2 holes. Capture my position. Threat tapped. Full, flat, depth is 2. And this is a M3. Yep. Now, do you see how it nicely and neatly found that outside curve and centered it? I love that feature. So I select anywhere on my model, and I just click that outside curve, and boom, that hole snaps right to that outside edge. So I don't have to sit there and align it and try to figure out how it's going to match. Hey, Patch, I do custom work all the time for people. That's cool. Just send me an email, man. All right, now I have my GPU anti-sag bracket. Now you might look at this and go, okay, how's that gonna work? Because it's gonna still flex down towards the tray. But remember, we have the GPU spacer out of acrylic. And at the end of it, I'm going to be putting right here and right here some neoprene foam blocks. So this will compress the GPU into those foam blocks. And I'm going to put a little bit of neoprene, like a neoprene strip, underneath this flange. So it's going to sandwich that card, hopefully quite beautifully. Yep. One thing I do want to do is I want to move it forward a little tiny bit. Something to keep in mind when you're designing parts, always plan for tolerances, because it looks like there's huge gaps in the computer, but they're not in real life. They're almost non-existent in real life. So one thing I do if I'm never gonna butt up a part against a bend like this right here. See, it looks like we can kind of fit it in, that notch, that curve right there, but in real life, it's not gonna look like that. So I wanna make sure that it's at least outside the start of that bend, and then it will actually be pretty close in real life when we go to assemble it all. Another added bonus is going to cover the nasty fan cables and RGB cables on that side. I just noticed though that I didn't make this bracket tall enough. I don't know what I did wrong. It's odd. Very odd. $8 millimeters. How did I mess that up? Besides being a dummy. All right, next part I need to work on. Again, I'm going to trim this in real life, but I'll keep the bracket here because you're probably not going to need this sag bracket. I could move the sag bracket even more towards the back of the case too, but I'm not going to worry about that either. So I'm going to put holes in my tray now. Clearance for an M3. And we have our trim panel covering that up, of course. Let's see how we're doing here. With our parts, how we can clean some stuff up. Your back looks a lot better. We have a brace. Okay, the next thing I want to focus on, I don't want to show all this huge bundle of cables exiting the power supply area. I don't want to show the riser ribbon. So I'm going to make a trim panel, an interior trim panel, that's going to try to cover these up and still look tasteful somehow. I don't really know how I'm going to tackle it. But let's see what we can come up with. If I use an SFXL, it's going to be a little bit longer too. Maybe what I'll do is I'll make like an interior panel with sky slots covering it. So it doesn't cover the fan for the power supply, since I don't know which model power supply I'm using yet. Because that's the thing, like, if I make this now and I don't use this power supply model, or this power supply, and I use like an SFXL, I want to have that fan incorporated into the design, otherwise it will look strange. So let's not sure what I want to do. It's a conundrum. What can I put there that will look cool? I know I don't like to make you guys wait, but winging this as I go along. It's gonna be difficult to figure out. I do want something though. Gotta clear the fan. Maybe I can just make a straight part, maybe come up a little bit. Where is it going to attach to? The back, maybe? Keep the front clean. Of course, I could just make the entire side sky slots, which looks really good, in my opinion, but I kind of wanted to leave it a little bit open and do like a spaced out panel. Let's worry about that in a minute. Let's go focus on this ugly boxy side. Work on that for a bit. Siegfried, there's already bays for 2.5-inch SSDs. I'm not going to be using them, but if you want to download the model, you already can download the O5L ready to rock and roll on my Patreon. I thought you were a Patreon member. That looks about right. That already helps things out a lot. You know what I could, well, I was going to say, what I could do is I could just cover it with the cover right here and just have a window for the graphics card and then a window for the motherboard, which could look okay. Do I have enough space for the power supply fan? Probably. Could use smoke acrylic, do a smoke acrylic window. And if I do that, then if I use solid black cables, it will help mask the cable loom down here. I could just put one dummy 2.5-inch drive, not a dummy one, just get one and I'd cover up the cables. That's how I designed it in the O5L. The drive covers up the cables that run underneath it. I don't know what motherboard I want yet, so I don't know how far the CPU fan's going to stick out. But I still also want to cover up this, the riser ribbon, because I don't like how... I want to do something special there. Okay, I have an idea. It might not be that great, but we can always just delete it later. So I'm going to create a new folder now because I'm getting to be, there's too many folders, too many different individual parts. Create new component. We're going to call this trim parts. And I'm going to move the GPU brace into it. I'm going to move the fan spacer, the rear trim panel, and fasteners into it. And this bracket into it. And I'm going to rename this cover working and tray working, and I'm going to name this T. Oop. And this C, so I don't click it as often. And I'm going to create a new component in trim parts. And this is going to be the cable shroud. Yes, Siegfried, there's a Patreon tier. If you pay me $300, then I send you a mini anywhere in the world. Hey, Mosquito. It's good to see you again. What about a hard riser I can attach a cover to? I do have a hard riser, and I can attach a cover to it, but this card's so thick, I can just cover the entire thing I wanted to. So I also want to kind of cover the slot up a little bit. So I'm not really worried so much how I'm going to attach it yet. I just want the look, and the look in my head, it just doesn't seem right. So let's do some sketches and figure out what we're doing. I'm going to start with a sketch this time instead of a body. No, I'm not going to start with a sketch. I'm going to start with a body and then sketch it out to change it. Create body. Is that about right? If we put a SFXL power supply, it will still have that hole centered. I don't need exactly the right dimensions quite yet. My goal was to leave this part a little skinnier, this part skinnier and come down. I'll try that. It's not near as big of a sweep as I was hoping. Put sky slots on there. No, that's not gonna work. We'll leave this part here. See if I can tackle this from a different angle. After I get the fan and the heatsink picked out and plugged in, maybe I'll make a window cover that's out of thick, dark acrylic, smoked acrylic down here, and it will just have a cutout for the fan. I do want to show off the nitro guy right here because that's going to be RGB and glowing. Going to be upside down, of course. I could make the case like this, it'd be right side up, but I like the idea of the graphics card being at the top. So without running a riser and have it be really ugly under the cable, not going to do that. All right, how much room do we have to put a acrylic piece? Quite a bit of room. Maybe I'll just have a window. Let's see. That needs to pass through. So window right here. Oh, I have an idea. I have a great idea. Problem is solved, I hope. Okay, watch this. 30 minutes later, the part will be done. I'm going to rename this to the side window. Actually, I'm just going to delete this. Goodbye. Go away forever. Ooh, I'm excited. I have an idea. Finally have an idea here. This will look cool, I think. Create box. No, it needs to be up higher. No! This is going to work. Alright, hide everything else. Tray, all this stuff. This, and this. The exhaust of the car is going to be great because it's going to come up here from the sides, right? That's where the majority is. So it's going to come right up and go through those sky slots. The intake's going to be great. And from the back side, you're going to see it's going to be fine. The car's going to exhaust beautifully. Good consideration, of course. I'm don't want the window to be this big, obviously, because it needs to fit together well, but I wanted to get it at least orientated correctly. So now I can come back and I can say -5 from the edge. I can make it actually more than that. Well, I want a little bit for the tape. Let's say 7. Let's look at 10. I can have... Okay, it's going to bolt from the top there. I think this will clear. I'm just going to use 10 for right now and come back later when I add the screws. This actually can go all the way to the edge there, but... Well, it can't go all the way to the edge. No, it has to at least clear there. We'll say -5. Give it some extra grip on the edge. And this was going to be... I'm deciding the thickness. Probably it'll be a 5mm thick panel. Let's do 3 to start. -7. I might make it a little thicker. Move this window over. Right there. I don't know which flat pattern it's complained to me about, but now we are going to hide the tray cover, and we're going to put the PC hardware back up, and I'm going to change this now back to our dark smoke acrylic. Add my sketch. Oop. And what I want to do is add like a little nameplate or name tag, like right in the middle here. And then I'm going to ramp up to it. And I think that will help the transition nicely. So I want to find my center. And I'm going to make a center rectangle. That's going to be 40 millimeters. That's 20 millimeters thick. Is that going to be high enough for my little... I think so. Now I'm going to make a line extending out to the edge of my window here. And one right here. And I'm going to -3. Okay, now I can work with this with my tray cover over. Oops, not my tray, my cover. I know that I want to move it down a little bit more, so I'm going to do that to start. Just a bit, right? Right there. We want to show off as much of the car as possible. And I don't know what I'm going to put there quite yet. Maybe the name of the mod or something. I don't exactly know. But I'm going to make this a little bit tighter. I don't think it needs to be quite so long. Let's do 30. Okay. Then I'm going to add some more fillets. I think it'll really come to life. First, I'm going to add my sky slots, though, before I do that. So I'm going to hide everything else. Hey, Jeremy. Long time no see. Hey, you're even a moderator on the channel. So, perfect. PC hardware. Sky slot pattern 2020, baby. Let's add them back in. This is how you put a model in the design for people who are asking later. You just right click on it and click insert into design. $270. Okay. We want the sky slats going front to back, so that's what we want. Stick it here. And get this somewhat positioned correctly. Gonna hide my window. No, that's not what I want at all. My computer lagged. Gotta do it again. It's not going to keep a sharp angle for people wondering about the nameplate quite yet. I'll show you what it looks like. Trapezoid might actually be better than what I had planned. We'll have to see if I like what I have at first. Computer is doing something. Golly. Alright, now we make our pattern. We make our pattern by selecting the first body, top one, this one, this one. Alright, and we click Create Pattern, Rectangular Pattern. And we want to go this way to start with. Choose how far I want to go, which is about right. Ooh, I actually meant to get my tray on there. Okay, that's correct. Good. And now I want to fill it in. So 3 is not going to cut it. We need like 13. We're going to do 12. 12 this way. And 5. And now we have an accurate sky slat pattern that is VESA compatible and everything. Now we don't want the sky slats going back down through here. Obviously that would look bad, so we're going to try to move everything around a little bit and see what we get. Otherwise we might have to eliminate one row of sky slots. It's going to be a lot of cuts in a laser. Now you can see that's 63 sky slots. You can see what adding holes to a project will do. That's a lot of laser time. I'm going to click, see. I should have deleted these because now it's going to keep them in the design history. But I suppose I can go back later if I want to. Right about there, huh? And we know we don't want, what's this one? Boop. 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 We come back up here and we go PC hardware. And we know we can get away with going down a little bit more, so let's go down a little bit more. Just a little bit. Well, actually I can't go down a little bit more because if I'm looking at it from the top, then there'll be a gap. So I'll be happy to keep it like this. So let's hide everything again and extrude it and make all those sky slots disappear from our very slow model. We want to hide this and we want to hide the PC hardware. combine, target body, and then we have the fun job of clicking 4, 5, 6. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 48 sky slots. I'm not going to keep the tools. Barney asked me anything particularly excites you for the coming year. I guess the S4T, like, I'm excited about the S4T. There's a lot of cool stuff with it. Yeah, and some of the accessories that Eric's been hard at work on. So, that's exciting. Hopefully it will cut and not crash. Cut, not crash. Cut, not crash. Yay. All right. Cool. Let's add our fillets. First, we'll start with the outside ones, which we know are going to be 10. And then the inside ones, we might not keep that so high, but because we do have some space now for the sky slots. But let's see what this is going to look like. All right, we want to unhide the PC hardware and at least unhide the cover. And we kind of just want to drag something like that. Something smooth that blends nicely. That I can put the name of the PC like engraved or cut through in there. So now we still have access to seeing the graphics card on the back side, which is important because that's the whole point, right? We still have a kind of a cover that's going to be well ventilated for our power supply and our graphics card. We will be able to see stuff through the sky slots, but that will look kind of cool. But they're going to help our brain not pay attention to the wires coming out the SFX power supply. And if I get an SFX-L power supply, you know, a lot of that's going to be covered even more by the acrylic up here. So I think that's going to be a reasonable compromise. What do you guys think? Meanwhile, Eric Peterson says, will the S4T be VESA compatible? And yes, it will be because it uses the official sky slot pattern. So it will absolutely be VESA compatible. Oh, you can't, can you even see it? I have to like hold it up above my face for you to even see the S4T. Oh, let's add our other parts, our trim parts. Fasteners, our plate, our spacer. Keep the power supply bracket off for now. But so far, this is looking pretty good. I am kind of happy with the front now. I am going to have my washers and my holes in the front. That's going to add to the design. Don't know where I'm going to put my on-off switch yet. It might still go in the front. Probably have room up here. Let's see if I can go find on eBay or something like a really big flat on-off switch. That would look kind of cool. I'm not going to use fasteners to fasten this window because I want it to be clean. So there's one of two things I'll do. I'll either add 2 lines here in the sketch and then CNC it so it sits flush with the side panel. If I have time to CNC it, I'm really pressed for time on this build. Or I can laser cut it exactly as is now, and I'll use some mounting tape on the back side. That way there'll be no screws visible. So left is the front bezel, which I might wait for last to figure out. And I want to do a stand. That's important. I want to do a stand. And I still can, if I wanted to, change the orientation of the computer case. Of course, I'd have to flip the Nitro Guy logo around. That's not a big problem. That has the benefit of the power cable being at the bottom, which I like. Also makes the graphics card's logo the right side up. The downside is that it will be somewhat top heavy, and the graphics card I really want to vent really well because the graphics card runs very hot. It's a 6800 XT hot graphics card, and even with a stand, I'd prefer if it was venting straight up, not hitting a table, you know, and bouncing out. So there's those considerations. Camden asks if this case for someone's order. This is for Sapphire. I'm doing a Sapphire build video. I don't know if you've seen any of my other ones, but that's what this is for. And I figured it'd be fun to do something that I can design, show you the design process, and then also show you how to get this made. So I promised that I would do that. I think I have one more day of streaming, but I'm getting really worn out. I've been doing this for a long time. I don't know how long I've been doing it, but I'm going to take a break either way. But before I do that, I do want to show you guys how you get these panels done. Hey TJ, good to see you. I miss you. So I'm going to save it. I might do one more live stream, maybe tomorrow, adding the fasteners, finishing up some of the final touches, putting a paint job in and rendering it out to see what it's going to look like. But for now, I'm going to show you how to get this stuff made. So I'm going to just pick any one of these panels. I'm going to pick the cover panel. Yeah. And this is what's so cool about using CAD versus like a modeling program like Blender or SketchUp or something like that. I can sorry, I lost my train of thought. Select my part, go to sheet metal, create flat pattern, click on a face of my my part, hit OK, and like magic, it squishes it down into a 2D profile. Very, very cool, right? So to get this ready for SendCut Send, the first thing I need to do, go to my bin lines, and I want to uncheck extent lines. Now, before you had to do a couple bit of extra pieces of work, but I think NFC Eric and SendCut Send have worked out some of the bugs, so you can just do this. So let's just try to start with. You can just hit export flat pattern as DXF. Now, you might want to do a sketch first if you have like countersinking holes and you want to choose the right side, because you want to obviously choose the side with the smaller hole rather than the bigger hole, otherwise it won't make a correct sketch. And to do that, all you would do is, let me hit cancel, you click create sketch, and then you click on your part, like so, and then you just close out. It's done, right? So then you go to your sketches and you right click on the sketch, and then you click save as DXF. But let's try to do it the other way first. export, okay, desktop, and this will be Sapphire O 5 L cover V1. Name it something really good that you can understand. And always put a revision number on it because you'll end up revising it several times for multiple reasons. I might end up revising it just to get it to work in the Syncadsen application. So hopefully it's created that DXF flat file. Camden, you're fixing to find out your answer exactly. Then we go over to syncadsen.com. And this is what it looks like after you create an account. I didn't do anything special. Obviously, I have parts in here already that I've made from Syncadsen. But I'm going to add this new part. So I'm going to click Select File. Sapphire O5L cover, DXF. Then it's going to process it. And we know that it worked because that's exactly what we want, right? We have our part here all smushed and floated out, and we have our dotted lines for our bend lines. And we obviously made this in millimeters. If you're not using Fusion 360, definitely check and see if these dimensions are correct, because other CAD programs don't necessarily export everything correctly, or rather the reader doesn't import it correctly. And then you can have something that's way too big or way too small. So Syncadsen has always been completely accurate for me using Fusion 360, but that's just something to consider. Don't just go buy your part without making sure it's the correct dimensions. I happen to know that this is about the correct dimensions. All right, the next step is we select what we want it made out of. Obviously, we're clicking metals. We want it made out of aluminum, but they have other products as well. And we want 5052. We do not want 6061, even though it's a luxury material. And we do not want 7075. That's aircraft material. Now you might say, well, why not? I can afford it. I want to have a nice material. And the reason is those are designed to be folded and flat and pushed and punched and bent with special tooling and special machines. If you go to make this yourself, you will not be able to bend that without cracking. It'll be very difficult to bend. You'll get sloppy corners that are round instead of nice crisp ones. And that's even if you can bend it. Over a long bend, 6061 or 7075, you may not be able to bend it on your homemade bender. 5052 is designed for this application. It's plenty strong. That's what you're going to want to choose. So I really recommend you don't choose another aluminum for making a case. Next, you're going to click your thickness. I went over this earlier in the build, but you want it as thin as possible if you're bending it. The thicker that it's going to be, not only the more difficult it will be to bend, but the sloppier your bends are going to be. And if you don't have a press brake, you're not going to get nice crisp edges. So you want as thin as possible. Now, I've made this design in 1mm thick aluminum, and it was okay. It works. It's a little bit too flimsy. I think 1.6 would be perfect for this build. Obviously I spec'd it out in the computer for 2mm. That's fine. You don't need to go back and change the thickness. I found that if you make it for 2mm, you can easily select 1.6. You can go under, no problem. It's when you start going over that you'll have a problem as far as the bending goes. You're just gonna have crisper lines going under. I'm just gonna click 2mm so you'll see the cost of 2mm thick. Obviously it'll be cheaper at 1.6. And right here we see the cost of our part. $45 to get this part cut out with a good amount of cutouts on it. This is just so phenomenal. It's so easy. It's so awesome. We get our part price right away. As you can see, they offer price breaks as well right on the website. But you can always call them up for a custom quote if you were doing 1,000 or 10,000 and say, hey, can we get a better price on this? And see what they say. But $45 for one of these parts, that's absolutely phenomenal. I like to get my parts cut myself or locally to support my local Accurate Edge cutting place. but Syncut Send is just, it's so awesome and so easy. You'll order this, you'll get your part very quickly. I usually get it within under a week turnaround if everything's working. That's even with the bad mail system that we have going on right now. Great, great, great. All right, click next. Now you'll have the options for deburring. Obviously select that. It's free, so why not? And bending, I'm gonna click bending. Now prices start at $29 and I think it's for 3 bins. And I'm gonna show you how this works. Now this, I'm very proud to say, is a plugin that was developed by NFC Systems. I can't take credit for it, but all the credit goes to Eric. He figured out how to fix the problem with the software on the back end for Syncut Send, so you actually can have Fusion 360 working right here. Because before you needed special software, maybe you could do it in AutoCAD or something, had different color bin lines. But thanks to NFC Eric, we now can do this in Syncut Send. And the guys at Syncut Send, they're so awesome to work with. Oh my gosh, they're so epic to work with us and be able to have this integrated. So here's our bin lines. They're all dotted. And it says right here, each bin line is associated with the color. Use our bin selection tool to indicate the angle. So red, 90 degrees, right? We want that bent straight up, and we can choose up or down. This particular part, I don't know which side it was. I guess they're facing forward. So we're looking at the bottom side of this part right now. So we want this bent down. Purple, down. Blue, down. Green, down. Now, something I noticed that there was still one more bug. Even though I clicked all these and selected down, in the back end it didn't do that for me. Maybe they have it fixed by now, but luckily the guys at Syncut Send are awesome, and they'll contact you and say, hey, which do you want these bin lines to be? And then you could just go mark like on a piece of paper what you want them to be, so it's not a big deal. And look, even though this was 4 bins, the computer is still saying it's $29. Even though they said that 3 bins was what the minimum was, or the maximum was. So that's a fantastic price for not having to do anything yourself. And Syncut Send has a press brake, so you'll get nice, super crisp lines. And our subtotal, $74 for this homemade part. I mean, that's amazing. This is... If you were going to buy this aluminum from, like, onlinemetal.com, you can go look up the prices, but I think the metal would be about $50, and then the shipping, you know, would be even more than that. So you'd actually end up spending more money just buying the material in small amounts to do it yourself. Now, of course, if you have access to a metal yard, you can go get a big giant sheet of metal, 4x8, for $300, $400, something like that, and then make a bunch of cases out of it. But then it's really big and you have to cut it down. So I think it's just amazing that you can get your part actually done and bent for less money than the material. Now, something to keep in mind too, that if I put cutouts all the way across here, it would be unbelievably expensive. So I'm going to show you an example if I have one. Let's look at this guy. Oh, there's no bin lines in this drawing, but we'll just add $29 to it. Look at that, $151. Basically the same part. There's a little bit more on that, but I mean, it's really all those cutouts. So you want to use as little cutouts as you can possibly get away with and make them cut out of acrylic or something else. Patch, I think Syncut Send right now is just in the United States, but there may be other kinds of companies elsewhere, but Syncut Send is pretty epic, pretty awesome. So I hope that this was a interesting video for some of you guys that are looking at making your own cases. I may do one more live stream where I just kind of pretty everything up. Maybe I'll save it for the video, the final reveal. I don't know. but I was really happy to be able to at least do this with you guys and talk about SimCut Send, which I think is just absolutely amazing, absolutely game-changing. I will be making a video of me building and assembling all this, and of course the last couple design parts and pieces I need to make. And hopefully I'll be able to include some clips of us doing the live stream for that final video as well. Ellen says, could you rate fan case designs? That would be awesome. I would just need enough people to send in designs. So yeah, for sure. I mean, if you do that, send it to my email address. Over time, I'll collect them. Then I can do like a live stream talking about people's designs if you'd like. But, you know, I'm not the most fascinating designer either, so take it with a grain of salt. I can only give you my personal take on things. All right, thanks, guys. Please stay warm. Again, go check out, see if you can give your homeless shelters, your local homeless shelters a call, and your food banks a call. Because, again, this weather, they're going to be absolutely slammed and out of stuff. So maybe you can drop by some food or something. I'm going to see if I'm about doing that right now. I have to get off the call. But stay warm. God bless you guys. And I will see you later.